Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Now today, I am thrilled to be joined by Jesper Therbo, Danfoss's Global Head of HVAC and Refrigeration in Danfoss Drives, and we're discussing a really important topic. It is using DC power and DC-Guard from Danfoss in data centers. We've discussed data centers many times on this show and their growing importance in our economy and their growing importance in power electronics. So I'm really happy to have Jesper here. Thanks for joining us.
Thank you, John.
Great. Do you want to introduce yourself a little bit and tell us about your role at Danfoss?
Yes, my name is Jesper Therbo. I'm heading our global HVAC and refrigeration business in Danfoss Drives. I've been 11 years with Danfoss, and I'm very keen to promote our solutions and ways to achieve carbon neutrality, energy efficiency, and also sustainability in all type of buildings, including data centers.
So let's jump in. What are the advantages of using distributed DC power data centers? I know we talk about AC drives a lot, but why is DC a good fit for data centers?
Well, John, around 4.2 billion people across the globe were active social media users as of January 2021. And this accounts for almost 54% of the total world population. And this number is growing year by year. And the virtual meeting activities and working from home are further boosting the amount of data flowing around the globe. And thereby the need for data centers to store and manage and share the rising amounts of data. So it is for good reason that data centers have reputation for being very big energy consumers. In what's considered to be a realistic scenario, data centers are expected to consume around 8% of global electricity production by 2030. And that's comparing to a little more than 2% today. Approximately 50% or half of the power supplied to data centers is lost in power conversions or power distribution, or used to remove the heat generated by these losses and by the IT equipment itself. So every time power is converted from AC to DC and back again, energy is lost, mostly in the form of heat. The fewer conversions the power supply undergoes, the lower the losses and the less heat generated. So there are obvious reasons to consider eliminating losses relating to these power conversions. Apart from the reduction in losses, the distributed DC power architecture in data centers includes significant fewer components than the current AC architecture, and fewer components take less time to install and service and reduce the risk of errors, which again increase the system reliability and uptime. Studies conducted by NTT reported a 10-fold improvement in reliability using DC compared to AC system. And finally, DC systems improve the quality of power supply and eliminate issues with unwanted harmonic waves and harmonic distortion.
Yeah, I mean, we just had one of our colleagues, Michael Strabolis, on the show talking about cooling in data centers and why keeping these data centers cool is so important. But keeping the power supply and reliability going is even more crucial. But with all these advantages for DC power in data centers, why is distributed DC not more common and existing, and even in new data centers?
I think, John, where AC power supply system efficiencies and architectures have been developed and optimized for decades, DC power systems have been somewhat overlooked. Probably the greatest challenge has been the lack of knowledge and experience among DC center or data center operators, owners, and contractors. There are relatively few DC data center architectures, and thereby not much data regarding their long-term performance and benefits. The availability of DC components is also still limited, and especially safety and short circuit protection have been areas of concern since it's difficult to ensure the required system functionality by using fuses. Ensuring selectivity and limited short circuit energy requires more sophisticated protection devices, and that's a challenge in a common DC system. It becomes even more challenging when there are several inverters connected to the same DC bus. In case of a short circuit in the DC bus, the protection fuses burn, but often so do the fuses feeding other vital equipment in the same system. So even fuses that are not connected directly to the short circuit can burn. For example, the fuses feeding inverters in another place in the same DC bus. Since capacitors can feed out current extremely fast, selectivity is difficult to achieve by only using fuses. So one way to improve total selectivity in a common DC bus system is to split the system into two separate DC grids using a fast current cutter or DC bus tie device. And Danfoss Drives has developed a new fast current cutter DC bus tie device, and that's the VACON NXP DCGuard.
Yeah, so it sounds like this technology is still developing. People are still getting used to it, and getting a handle on it. So tell us a bit more about DCGuard and how that's helping the industry really develop around DC.
Yeah, in short, the VACON NXP DCGuard is a device that maintains the safety and stability of DC grid systems by providing short circuit protection. This means by detecting and cutting off any faulty DC currents very fast, really fast actually, just within 50 microseconds, and thereby protecting the surrounding equipment. It enables connection of two different DC grids with voltage differences, and most importantly, it prevents accidents or injuries. The semiconductor protection device is based on standard VACON NXP inverter hardware and new software. During a short circuit, the VACON NXP DCGuard disconnects the healthy side from the faulty side in microseconds before the short circuit affects the healthy side. The fast isolation ensures that the healthy side can continue to operate as normal after the short circuit situation. This means VACON NXP DCGuard enables a secure DC grid and is also a key enabler for DC network use in many different applications such as data centers, commercial buildings, or factories.
And we know, especially in data centers, that redundancy and having that redundancy available is incredibly important. We don't want downtime. We don't want these data centers to go offline. So, being able to reduce energy usage, reduce losses with the DC component, and then also adding this redundancy, I think is incredibly important and makes DCGuard, really valuable technology going forward. What's new about the technology as we head into 2022 and beyond?
Well, if we look back traditionally, an AC drive is used for rotating a motor at variable speed. Inside the drive, IGBTs create the variable voltage and frequency required to adjust the speed through DC voltage pulses. This way of producing a sinusoidal voltage is known as pulse width modulation, or PWM, and involves switching the IGBTs on and off several thousand times every second. To avoid damage when a voltage is applied the opposite way across IGBT, all VACON NXP hardware is equipped with diodes connected in parallel to the IGBTs. The diode will protect the IGBT against damage and at the same time allow reverse energy to return to the DC link capacitors, and this type of diode is often named a freewheeling diode. So the VACON NXP DCGuard IGBTs will connect the DC terminals to the output terminals, making a fixed path for the current passing through. All current passing through the VACON NXP DCGuard will also pass through a serial connected inductance, and this inductance will limit the current rise time, it's also called the DIDT, to a level that makes it possible for the VACON NXP DCGuard to measure it and act. Most importantly, the IGBTs are designed to cut off a DC current and can do it without being damaged or worn out.
Yeah, and it's this mixture and combination of hardware and software. I think that makes it so exciting and really, bring this technology to bear and make it applicable for 2022 and beyond and moving into the future. So, as we wrap up here, we're always talking about sustainability. We're always talking about decarbonization here on the podcast. How is DCGuard helping data center owners and operators become more sustainable as really we find this becoming a bigger part of our lives?
Yeah, short circuit handling has been one of the hurdles for wider uses of DC power supplies in data centers, and it's difficult to ensure the required system functionality by using fuses, and therefore data center owners and operators have not harvested the advantages of using distributed DC power supply in their data centers. Apart from the tenfold reliability enhancement I already mentioned, DC supply can offer a 10% boost in supply to server efficiency. It can reduce infrastructure investment costs by around 15% and bring down the amount of space required inside the data center by around 25%, meaning more floor space for server racks and for highly efficient cooling solutions. When it comes to meeting the aspirations for green and sustainable data centers, DC systems make it much easier to integrate on-site renewable energy sources such as solar, fuel cells, or wind, or energy storage devices that produce DC power. So all in all, VACON NXP DCGuard is an innovative enabler for data center owners and operators to harvest the many advantages of deploying distributed DC power systems in their data centers.
Yeah, and I think that as we get into a more sustainable future, we see more renewables coming online, more storage. DC power is going to be a big part of that, and I think this type of technology is going to be incredibly important. Well, thanks, Jesper. This was a great conversation. I think really timely. Thanks for joining us. Any final thoughts?
Yeah, I'm very excited to see the VACON NXP DCGuard becoming an addition to our portfolio of energy efficient solutions for climate, inside and data center cooling. And I expect the DC power supply to really be something we'll see growing rapidly in the future.
Yeah, and I think that's absolutely true. We're going to hear more and more about DC as we kind of head into the future in data centers and in other applications too. Well, thanks, Jesper. I really appreciate it. Again, my guest, Jesper Therbo, Global Head of HVAC and Refrigeration in Danfoss Drives. And that's it for this episode of the EnVisioneering Exchange. Again, I'd like to thank Jesper for joining us. Don't forget to subscribe to the EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share with your network. Thanks again for listening. My name is John Sheff, Director of Public and Industry Affairs at Danfoss. We'll talk to you next time.